The sun is the source of most of our energy here on Earth. Energy from the sun is used to produce electricity using photovoltaics and solar thermal plants. That same energy is also used for heating using solar domestic hot water systems, hydronic heating, solar air heating, and solar cooking, just to name a few. This video will talk about how the sun produces that energy. The sun produces energy using a process called fusion.
Conduction is one fraction of heat transfer, and a good example for conduction is a hot kettle. Ouch! Convection is another fraction of heat transfer, and that is heat moving with air, and a good example for this is a hairdryer. Radiation, the last fraction, is heat transferred by electromagnetic waves. And that's me 2 weeks from now.
There are two collector types to choose from: flat plate and evacuated tubes. Evacuated tubes have the advantage of receiving perpendicular radiation for a greater part of the day. This, combined with their vacuum insulation, means good winter performance. Flat plate collectors, particularly if purchased as part of a closed couple system, can be more affordable than evacuated tube collectors. However, the prices of evacuated tubes has fallen in recent years. Collectors should ideally face true north in a shade-free position. Facing the collectors 45 degrees from the north will result in only minor reductions in performance. The ideal inclination is the angle of latitude plus 5 to 10 degrees. Sydney's latitude is 33.5 degrees, so an ideal angle of inclination would be around 40. However, plus or minus 15 degrees would still provide adequate performance. If your collectors face due east or west, the lower the angle of inclination, the better. However, to allow thermosiphon flow, you must always keep the angle above 10 degrees. For the correct sizing of your collectors and tank, consult manufacturer's guidelines to see what is best for the climate and household. In places with minor frosts, evacuated tubes may offer enough inbuilt protection. In climates with regular frosts, indirect or closed-loop systems are the most popular and reliable form of frost protection. Instead of water, an antifreeze fluid is heated in the collectors. The antifreeze passes heat onto the water via a heat exchanger. The antifreeze does not come into contact with the household water supply. Other frost protection methods are available, such as frost protection valves, temperature programmable pumps, and drainback systems. In an Australian summer, water in collectors can easily approach boiling point. This can cause excessive pressure buildup and can damage the lining of vitreous enamel tanks. The Australian standards state that solar hot water systems must provide over-temperature protection without draining water, so a temperature pressure relief valve is not enough. The most common way to prevent overheating in the tank is by automatically stopping the circulation between collector and tank when the tank water gets too hot. This can be done using a solar control valve or a temperature-controlled pump.
An insulator is something that isolates or protects something else, or something that prevents electricity, heat, or sound from escaping. This coat is an insulator because it is protecting me from the cold and is not allowing the heat from my body to escape. This coffee mug is an insulator because it is preventing the heat of the coffee from escaping. These flamingos' feathers are insulators because they stop their body heat from escaping. The fur on these lions is an insulator because it keeps them warm when it is cold. This wire has a rubber insulator around it that stops electricity from escaping. This material is called wall insulation. It is in the walls of your homes and schools. It prevents heat from escaping and sound from traveling through walls. Insulators do not allow electrons to pass through them easily. Things like glass, rubber, wood, and plastic are often insulators. An insulator isolates or protects something, or it prevents something from escaping. What insulators can you find in your classroom?
In this exchange causes the warming effect known as the greenhouse effect. This phenomena is known as the greenhouse effect because, like the glass in a greenhouse, the atmosphere traps some of the energy beneath it. The greenhouse effect produces a warmer climate on Earth than would be possible without an atmosphere. In summary, water vapor and
to the hot sun?
Yes, indeed. First, let's talk about the heat, since that's really what this case is all about. Now, believe it or not, heat is a form of light.
What?
Here, Mr. Savage, take this flashlight and shine it at this mirror.
I can't see.
And why not?
Because the light is reflecting back into my eyes.
That's right. Now, the important word here is reflecting. Because now, Mr. Savage, I want you to shine the light at this old piece of wood. Okay, good. Now what's happening?
I'm still having trouble seeing.
Very good, Mr. Savage. So where does the light go?
Some of it gets absorbed in the wood.
Absorbed into the wood?
That's right. The light gets absorbed right into the wood.
You mean like a sponge?
Well, yeah, I guess. Well, heat can be either reflected or absorbed, just like light.
I don't get it.
I'd better show a demo. Fred, could you turn on the laboratory sun lamp, please?
Okay.
Hey, the temperature's going up.
Now, do you know why?
Because the sun lamp is very hot.
Well, that's right. But look, the thermometer with the black shirt is heating up faster.
So that explains why Mr. Richmond was very hot and felt faint.
That's right.
Just because of the shirt color?
That's correct. The black absorbed a lot of the heat while the white reflected it. Do you know why a white shirt like this looks white to us?
Because it's white?
No.
How could I have missed that one?
It looks white because it is made in such a way as to reflect light and heat. The white color you see is actually reflected light and heat coming off the cloth.
But the black cloth of this shirt is not reflecting any light or heat, is it?
No, ma'am, it isn't. It's sucking the heat and light in and trapping it, getting hotter and hotter.